Well, hello friends. Welcome back to the JavaScript bytecode series. We are just going to continue, so if you haven't been watching from part 1, I really recommend starting at the beginning. But today we're going to be implementing continue statements in the bytecode environment. So basically, we'll make a test program. Well, we don't have 4 actually, so I guess while something... Oops. I is I plus 1, and then if I is not 2, then continue, otherwise let's print something. Not 2. Or wait, it's not 2. Okay, so that's a little weird program. But it should print 2, and the current JS tree walk interpreter obviously handles this case just fine. If we try to run it in the bytecode generator, it fails because, well, we don't know what to do with continue statement yet. So let's figure out what to do, and we do have a bit of a tricky situation here, because the way that continue works in the tree walk interpreter, the AST interpreter, is that we just tell the virtual machine to unwind to the nearest continuable scope. And this is sort of we have this mechanism where you can tell the VM, hey, I want to unbind to this type of level, and then the VM will just sort of recursively unwrap the call stack, or the AST interpreter will recursively unwrap the call stack by just short-circuiting all the way until you are at the right type of level. And this is done in all of the different nodes using this should unwind and should unwind until. So in a while statement, for example, when we execute that, after we execute the body of a while statement, we check, are we supposed to unwind now? If so, should we unwind until continuable, and so on, and blah, blah, blah. So the way unwinding works, basically, it's littered all over the AST interpreter. And we can't really use that in the bytecode environment because we have to... Well, we don't have the AST on hand, right? So we have to do something different. So I think what we want to do instead is just generate jumps, basically, so that if we look at our code, if we perform a continue here, we really just wanted to jump up to here, right? And really to like jump up and perform the test expression again. So I think it should be enough to just emit a jump back here. Of course, the tricky part is like, how do we know where to jump to when we encounter this thing? But I think if we can like remember what sort of what continue scope we're in, or I guess continue and break share scope type. So let's just start by adding a generate bytecode generator for a continue statement. And then we'll go to ast codegen. And now to do something smart. So what do I want to express here in a continue statement? I want to say jump to the nearest continuable containing scope. So generator emit like a byte. This can really just be a jump, right? Because we do have a jump. and we want to jump to the generator's nearest continuable scope. I mean, something like that, or maybe we should call it label. Nearest continuable label. Not to be confused with labeled statements in JavaScript. So actually, the way that we're using label in the bytecode generator is a little bit unfortunate because it does clash with the labelable statements concept in JS, which is you know, something like foo : right? You can do this, I think, and then you can do like that. But let's not care about labelable statements at this moment. I'm just realizing that the name label here is kind of unfortunate because, or maybe it isn't. I don't know. I'm overthinking. Let's plow forward. So nearest continuable label, let's say. Nearest continuable label. Okay, and how do we know where that was? Well, when we enter into a while, we want to jump to the test, right? So we want to jump and perform. If you do a continue, we want to jump back here and perform the test again. So, I mean, I guess the first thing we can do here actually is to just do nothing. Just verify that this runs, or that it compiles, which it doesn't, of course. So I think when we entered into the while statement, we can just like push the scope label onto a stack and then pop it when we exit the while statement. Missing generate bytecode for... Maybe it would have been nice to print out which one is missing, but I'm just going to use Valgrind to get a stack. Scope no generate bytecode while statement. So something in the while statement. Okay. Oh, if. Oh, shoot. We don't have if. Oh, I forgot we don't have if. Okay, okay. That makes sense. All right, all right. Let's quickly add if, I guess. Virtual optional bytecode register. Generate bytecode. I feel like I'm writing this line over and over, but somehow it's nice to write the same thing over and over sometimes. I don't know why I like that. It feels like it's like a chance to breathe or whatever. So, okay, so we'll start by just doing the if statement then. Since we're here anyway, and it shouldn't be that tricky. So if statements have an predicate, a consequent, and an alternate block, or statement rather, and the alternate is optional. So let's see. First, we generate code for the, what was it called? The predicate? Predicate, yeah. Predicate, generate bytecode. Okay, and then if the predicate is true, then we should run the consequent block. So let's call it the if jump, maybe. So emit bytecode op jump if true. Then we want to jump to somewhere based on the predicate reg. Okay, so we'll call it the if jump and the else jump. So if the predicate is false, then we want to jump to the other place. Wait, why don't you like these? Oh, right, because these are optionals. Okay, and then we have to link these later because we don't have the code yet. Okay, so then we generate the code for the, or wait, hold on. The if jump has to go to here. So set target, generator, make label. So that one goes to right here. And then we will spew out the code for the consequent block or consequent statement. And followed by a jump to the end, I think. So end jump. Because we have to jump over the else, or the alternate block. So jump to, well, we don't know where to yet. And jump needs to support not passing a target up front. So we'll do this so that you can set the target slightly later. Okay, I think we're good. Probably have to put some stars here and there. Nothing too crazy. Jump and jump. All right. And then, let's see. So if we have an alternate, then we will generate code for it here. And also we will link the else jump to here, actually. Set target to generator make label. So the else jump goes here, and then maybe the else jump always goes here, because if there's no alternate block, the else jump should also jump to here. Okay, now we shit that out, and can we just fall through at that point? And jump set target generator make label. Ooh, am I getting this right? Also, what does if statement execute return? Undefined, or the result from executing the blocks? Sure, okay. Okay, I don't know if it's important to preserve that behavior. That's going to take some contortion if needed. So I'm just going to put fix me. Do we need this to return the consequent alternate result? That's what the AST interpreter currently does. Yeah, I'll leave a fix me about figuring that out, because if so, we have to do some additional things to make sure that it ends up in a register in both cases. Because I don't know if it's necessary. It wouldn't be too tricky. You just allocate a register and make sure that both paths put the result into that register. But anyway, let's see. Oh. So what does this do? Jump. We jump to here. If the predicate is true, jump to else jump if it's false. So we just jump past the consequent. Sure. Sure. That seems fine to me. So wait, what happened when we ran it? It prints 222. So that's obviously not right, but it's because our continue block, our continue statement doesn't work correctly. So let's see if we can jump to the nearest continuable label. Or you know what, actually, let's first check if the if statement works, since we wrote an if statement and everything. So I is 3, if I is less than 3, console log less than 3. Okay. Ooh, let's get fancy here. I equal 3. Else console log more than 3. Oh, wait, hold on. We don't support equals? Okay, let's be a little crafty here. So what did this print? Exactly 3. And if we do 2, it prints less than 3. And finally, 4, more than 3. Our if statement works. Fantastic. And look, even complicated business like else if just works too, because of course the parser turns that into an else block with an if statement in it. So something like that, right? Or wait. What am I doing? It should become this. Wow, I'm fantastic at Vim. Okay. Anyway, so let's commit the if statement first then, since we went and did that. So not you. You have to break up. Not you. Yes, you. And also you. Okay, so we have to do a little bit of surgery there. Just some minor. And then we'll undo that and commit. Add basic if statement support to the bytecode VM. This also required making bytecode op jump support lazy linking to a target label. Yeah, that makes sense. I left a fix me here about having the if statement return the result value from the taken branch statement. That's what the AST interpreter does, but I'm not sure if it's actually required. Yeah, that's why it's a fix me. Okay, so let's try to do that continue thing. So how do we get to the nearest continuable label? Well, what if the while statement simply pushes, I think that's the train of thought I was on before the if statement sidetracked me. So here, like right before we perform the test, actually, at the head, or at the very top of a while statement, we could do something like generator push continuable scope, or continuable enter begin continuable scope, let's say. Scope is a little bit overloaded, but I think maybe it's okay. So the continuable scope begins there, and where does it end? It ends after the body, I think. So here should be fine. and continuable scope. Okay, so let's try this concept. So this would just be a matter of having like a vector of label, continuable scope is nearest continuable scope, let's call it. Yeah, okay. And then begin continuable scope. And continuable scope. Yeah, because these go on a stack, right? So if you have nested, that should still take you to the right place. If you have nested for loops or while loops in the same function, for example. So wait, so then these simply have to return label generator nearest continuable scope is just return m continuable scopes last, and then begin, we'll just do continuable scopes append the current label. And continuable scope will m continuable scopes take last. And that will actually verify an assertion fail if the thing is non-empty, or if it's empty, rather, if the stack is empty. So that should be good. And what did we call that? Nearest continuable scope. Cool. So now it prints 2. That's exactly right. Yeah, that's pretty cool. Pretty cool indeed. And if I wanted to do this, not to, then then of course it doesn't work because we don't support equality checks. We can implement that actually. Let's just commit the continue statement. Oh, and let's also add this for do while. So in the do while case, I mean, actually it's the same basic idea. Continue takes you to the start. So begin continuable scope. And I guess we have to end the continuable scope before performing the test at the bottom. Otherwise, it might get confusing if something inside of the test tries to continue. Although the parser should prevent that from actually happening, but it still feels cleaner to exit the continuable scope before we evaluate the do while test. Yeah, let's do it that way. Okay, so libjs and basic support for continue in the bytecode VM. This only supports, note that this only supports bare continue, not continue with label. Oh, I mean, I should actually write a little bit more about that. No, this is just unlike the convoluted unwind until scope type mechanism in the AST interpreter. Continue maps to a simple jump bytecode up jump here. We know where to jump based on a stack of continuable scopes that we now maintain on the bytecode generator as we go. Yeah, and then we'll put this at the end instead. There we go. Beautiful. And then what was the last thing I wanted to do? Just add, I think, abstract equals, right? So that we can do just equality checks. So we have abstract in equals. So let's just implement abstract equals. It takes basically no work, just a little bit of copy paste and a little bit of copy paste work and removing an exclamation point. Where are you? Here. Okay, and then we just have to teach it to generate that bytecode op for that binary expression. Coop. Coop-a-doop. And then we get two not twos because there are two not twos in the 0, 1, 2 series. That's awesome. Can we print that out? Oh, in the 1, 2, 3 series, my bad. Right, we increment first and then compare. Right. So 1, 2, 3, not 2, 1, and 3. Beautiful. Oh wait, what am I trying to do? Check out my Bytecode VM branch. I'm already on that branch, bro. You can't hurt me. So yeah, that's just really straightforward. So let's commit that. Libjs. Add bytecode op, add abstract equals bytecode instruction for comparison. Cool. That was nice and straightforward. So I think that's going to be it for today's video. Got some additional control flow implemented. So now we have if statements and continue statements without labels, but still. And then we also did a little bit of extra binary expression implementation. So, you know, we're moving forward here, step by step, little by little, figuring things out as we go. I think this is going pretty well. I feel like this is going at a pace that I can handle learning. So I hope that it is interesting for people to see. And I hope I haven't made some devastatingly bad design decision that will force me to rewrite a lot of this, but I think it's on a decent track. Somehow it feels like it is. So I'm just going to keep pushing forward in the next video. So I hope that you are enjoying the series so far, and I will see you in the next one. Thanks for checking it out. Bye.